Okay, section 2.4, inverse functions. Okay, so we're going to talk about inverse function notation. We have talked about function notation, but now we're going to talk about inverse function notation. So let's take a look at the first example. It says, recall the phone example from earlier. Well, we didn't have a phone example earlier, but where the calling plan charged us $30 a monthly service fee and 10 cents per minute for long distance calls. Well, obviously this is a little old because we used to have to pay for long distance calls. Now you guys have cell phones, so that's no longer the case. But we're gonna work on this problem anyway. So if you look at this T is the time in minutes. That's your input. C is your output. So C, our output, is equal to F of T, which is our output. Again, T is the output. F of T, T is the input. F of T is the output. So we've been already talking about that. But there's another notation, which is the inverse notation. If I take the inverse of C, that is asking me to find the T. Okay, so this notation means find the input. This is the output. This is the input. Okay, this represents input. So in this case, we say the cost, C, is a function of time, T. This here is saying time T, written as a function of the cost. In this case, C. Okay, so a little bit different. So let's take a look at this. This is a review here. F of 36. F of 36. Input or output? That's output. 36 is your input. So T is your domain. So 36. The output is 33.60. Now what does that mean? Interpret that statement. So 36 minutes. It's saying if you talk for 36 minutes, on long distance, if you talk for 36 minutes of long distance, your phone bill is $33.60. Okay, but let's look at this notation. Does this mean they want to know what the output is? So is 36 our input or is 36 our output? So in this case, it's the inverse notation. Inverse notation. So 36 is our output. We're thinking backwards now. So if 36 is our output, our input is 60. So what does that represent? Well, again, this is what we're being given. So it's saying that the opposite of this here. It's saying if your phone bill is $36, then you talked for 60 minutes of long distance. Okay, so they're inverses of each other. Okay, you try the next one. If this is given here, what goes here? I'm going to give you a hint. Another way of looking at this inverse is blank of f of 33. This means what does f of 33 equal? And the answer is 33.30. 33.30. So again, this is the given. So what is it saying? It's saying you talked for 33 minutes long distance. So your phone bill is $33.30. Okay, so function notation and inverse function notation. You need to know both. Okay, so let's try some problems. Let's look at the next page here. Okay, let's try the first one together. A. Find f of 2. That's saying that 2 is our input, f of 2 is the output. So what's our output? Right about there. Well, these are going by halves, so it's not quite 1.5. So let's just say approximately 1.3. Okay? Now you go ahead and try this one. What is this saying? Is this 2 our input, like it was over here? Or is this 2 our output, if we're thinking backwards? So this 2 is our output. So we go to where y is equal to 2 on the graph, and we give the x value. So again, it's going by halves, so that's 3.5. Okay, stop the video right now and try C through I on your own. Okay, hopefully you tried those on your own so you could get some practice. Here are the answers for you to check. C is 7, D is -4, E is approximately 2.7, F approximately 5.4, G, again, we're approximating about 2.4, not quite 2.5, but close enough. Okay, H is equal to 5, and I, again, I is saying X is equal to G of 0. Okay, x is equal to g of 0. Now, when I say x, I just mean your answer. This answer right here. Don't get confused. This is saying what is your output when x is equal to 0. So don't let that one's a little confusing. So what do you get for that? What is g of 0? Okay, well, we're looking at this table for for g. This was f, this is g. So make sure you're using the right ones. Hopefully you were using the right ones. If not, stop the video and go back, f and g. So if we go to this table right here, g of 0, the answer they want is 7. Okay, f, you use the f graph, g, you use the g table. So if you have to stop the video and go back and try those again. If not, if you have any questions, make sure you ask. Okay, let's go ahead and look at the story problems. Number 2, it says A equals f of n, so that means n is your input, f of n, or the amount of periwinkle blue in gallons, is your output. So right here, this input, it says needed to paint n square feet of our house. So what is this telling us? This is saying that we have 20 square feet of house to paint. So what does this function notation represent? The amount of what? It's the amount of periwinkle blue paint, we'll just say of paint, in gallons needed to paint 20 square feet of house. Okay, now see the difference here? What does this one mean? What is this 20? Okay, is 20 our input, or is 20 the amount of paint? 20, you gotta think backwards. 20 is the amount of paint we need. Okay, so what is, or I should say the amount of paint we have. 20 is the amount of paint we have. We have 20 gallons of paint. The question is, what does this notation mean? What does it mean, f of -1 of 20? Now don't do any mathematical operations with that -1. That is just inverse function notation. Don't be multiplying by -1 or dividing by -1 or flipping it over or anything like that. This is inverse function notation. So normally this whole thing represents our output, but this notation here represents what? That's what they're asking us for. It represents the number of square feet of house that can be painted with 20 gallons of paint. Okay. All right, last example here. It says if cricket chirps r times per minute, then the outside temperature is given by this formula here. So R is our input, F of R, or temperature, is our output. Find a formula for the inverse function. Find a formula for the inverse function of T. Okay, so let's start with the given formula. Let me write that down. If T equals 1/4 R plus 40, what is R? No, we just have a math problem here. Oops, 40, not 400. Sorry about that. So if you're trying to solve for R, what would you do first? Well, I would subtract 40. So T minus 40 equals 1/4 R. To solve for R, R is equal to 4 times the quantity. You're multiplying the entire side by 4 to get R by itself, or R equals 4T minus 160. So this is T in terms of R, and this is R in terms of T. Okay, well, if this up here is F of R, okay, this right here, when you rearrange the equation for R, that's going to be your inverse notation. So T here is the variable in this equation. So the other notation, the inverse function notation, would be the inverse of T equals 4T minus 60. Inverse function notation. Okay. Okay, so now that we have those formulas, let's see if we can calculate and interpret these. Let's do this one. This is, again, what we've already been doing. Find F of 50. Find F of 50. Well, we're going to use our F of R equation. Okay, F of R equals 1/4 R plus 40. Okay, this 50 is our input into this equation. So 1/4 of 50 plus 40. 50 divided by 4 plus 40, that is 52.5. So what did you just calculate? We were given R equals 50. What is R? What is R? Okay. So R is the times per minute the cricket chirps. So when a cricket, not chirp, chirps. When a cricket chirps 50 times per minute, the outside temperature is 52.5 degrees Fahrenheit. Okay? But what does this notation mean? When this is the given. So this f of -1 of 50, we're going to use this equation. Okay, now you could use this equation, but is this the r or is this the t? Well, it's the t. So if you use this equation, you'd get the right answer. But since we already have this solved for t, we can use that one. Okay. So inverse of t equals 4t minus 160. So that means that when the temperature is 50 degrees Fahrenheit, we end up getting 200 minus 160, we end up getting 40. 40 what? 40 chirps per minute. So interpret what's given. So again, this is temperature. So this one is saying when the temperature is 50 degrees Fahrenheit, just to be clear, a cricket will chirp 40 times per minute. Now, I don't know about you, but I've got a lot of crickets around my house. So maybe somebody can see if this formula actually holds true.